Hello, and I believe this is a good day. I hope you are enjoying your weekend. I just feel we just try to cover up some of the lost time by doing this recording to listen to it. And I've decided to start the lecture from the beginning for the benefit of those of you that couldn't join us when we had our last class, and also because of the break that we had in the transmissions. So I will just rush through our first discussion. In our first discussion, we tried to look at the overview of the host defenses. Remember, we talked to ourselves about the fact that human beings are capable of protecting their body as part of the natural prevention of the body system, which is what we study in immunology. We divide that to the innate defenses and the acquired defenses. We say the innate defenses are those that are not specific. They include physical barriers, chemical mediators, and cellular systems. And then the acquired immunity are those that develop over time, because they are able to discriminate between what is self and what is not self. They have memories and they cause cell tissue or body system that gets involved in it. So essentially, we talked about three features that we emphasize: specificity, memory, and tolerance, which you said are the things that mark the immune system. They are features of the immune system. So for today, really, what we want to look at is to move into immunology proper. We're looking at two macromolecules, antigens and haptins. These are macromolecules that, by general word, I would say they are foreign to the body. The term antigen was actually coined to refer to those compounds that elicit immune response, which is characterized by the production of antibodies. And it's derived from two words actually: antibody generation. And that's what you find on the slide there: antigen, antibody generation. The anti from the antibody and the gene from the generation. To any macromolecule that is able to elicit specific reaction either with antibody or with a lymphocyte are referred to as antigen. Another word that's similar to it is the immunogen, which is, as you can say, any macromolecule or substance that elicits or triggers immune response, immunity generator, that makes the body to react. So these are the things that we'll be looking at. Now, very quickly, let us get to understand that it's not everything that triggers immune response that is an antigen. So antigens are different. All antigens are immunogen, but not all immunogens are antigen. And that's where the word haptin comes. So haptins are another set of molecules that we'll be looking at as we go along. The antigens are usually large macromolecules are complex, and because of their large complex nature, they're usually about 10,000 daltons in molecular size. And because of their large size, they are able to function as antigen. So the ability of any macromolecule to function as antigen depends on three or four critical things that we're looking at. Number one is that it must have a large size. Number two, it must be structurally complex. Number three, the chemical nature of it will determine to how much extent it will function as an antigen. If it's similar to the molecules that the body is used to, then it is not likely to elicit so much of immune response. But the more different it is from what the body usually sees, the easier it is to see immune response, and which is also the degree of foreignness of that macromolecule to the body. These are the things that will influence whether or not the macromolecule acts as antigen. So the antigen has parts of it that we refer to as region or sites that bind or react to the antibody that it stimulates the production of, or the T cell receptor that is going to act on. That region is called the epitope or the antigenic determinant. That is the region or site of the antigen that reacts with the antibody or with the T cell receptor is called the epitope or antigenic determinant. This epitope could be any form of macromolecule. That include organic acids, it could be organic bases, it could be amino acids, it could be side chains of amino acids, it could be hydrocarbons, or it could be aromatic compounds. And then these are various forms of epitopes. And usually, for some antigens, they may have more than one antigenic determinant. And that is what is called the valency. The number of antigenic determinant or epitope that it has is referred to as the valency. The valency of that antigen will determine the number of antibody that it can bind to at any particular time. Usually, when the antigen has only one antigenic determinant, we refer to it as a monovalent antigen. When it has more than one, then it's called a multivalent antigen. And usually, the multivalent antigens are better in eliciting immune response because they have more antibodies that they can bind to at a time. What also encourages the higher or stronger immune response by multivalent antigen is because it is possible for the multivalent antigen to cross-link antibodies so that two or more antigens can be hooked up to like 3 or 4 antigens. I'm sure you remember what the antigens look like. If you just look at what I'm going to draw there, we say our antibody has a Y shape. So this will be an inverted antibody. Let me try and make it better. Let's say it's another antibody. Never mind by. So let's say these are 2 antibodies. So we could have if this antigen that is multivalent, we will bind with that, combine with that. Maybe I should have picked a different color so that you could see. So let's say this is the antigen. So let's say that's the antigen, multivalent antigen. If we have another multivalent antigen somewhere here, this we could bind to this and still has one more free. So just these 2 are bound to this. This can bind to. So if we pick again, let me see, I have another antibody here. So you can see 2 of the antigen binding to several antibodies. So that is what we are talking about here. I'm talking about cross-link. Let me make this look decent so that anybody that's looking at it will not accuse us of misrepresenting what we are doing. Okay, so I believe we are comfortable with this. So let's assume these are our antigens and antibody reactors. So that's what we mean by cross-linking antigen and antibody. Now, the other thing that we also want to talk about the antigen is what we refer to as the antibody affinity. That refers to the strength with which the antigen binds to the antibody at any given antigen binding site. That's the extent of their bonding when they come to react together. And then the antibody also has what we call the avidity, what's the overall ability of the antibody to bind antigen at all its FAB regions or FAB sites. We'll come to what FAB site is as we go on in the lecture. That's the fragment that is antigen binding, which is the point at which the antibody and the antigen interact. So let's carry on with our discussion. So that's much about antigens. So let's go on to look at haptens. So haptens are macromolecules just like antigens, which are foreign to the body. But in the case of haptens, they are usually small organic molecules and cannot on their own trigger immune response. That is, they cannot trigger the production of antibodies or bind to T cells they need to be attached to larger molecules before they will be able to trigger reaction. But that's the example of what you find here. They are foreign to the body, yes, but on their own they cannot do anything in the form of triggering reaction. So here we find a summary of the properties of immunogenes. Remember we said immunogenes are those macromolecules that are foreign to the body that trigger a immune response. And we have categorized them into two, antigens and haptens. And the basis of categorization, we find those 6 properties, some of which are intrinsic, that is, they are properties that have to do with the macromolecules themselves. And then the other set of properties are properties that don't have to do with the macromolecules themselves. They are external to them, which is called the intrinsic properties. The intrinsic ones are those that are properties of the immunogenes, while the intrinsic properties are those that are not necessarily properties of the macromolecules. So the first one we'll look at is size. The bigger you are, the better it is. The next one is complexity. Polymers act better than monomers. Monomers are smaller units, and then the form in which they are. If the foreign material is in aggregated form, it serves better as immunogene than if it's in a soluble state. Then, what are the things that will affect how it reacts that are not a part of the properties of the immunogene? One is the dosage. The more the quantity you give, the better it is that it's reacting. So